We are now moving on to decimals. This will be the second half of the revision slides. Let's get to it. So, when dealing with decimals, okay, you place a value table. It's like just extends. So, basically, the main things you gotta know are basically these bad boys right here, and this one in particular, the decimal point right here. Let me just circle it in. That's very important, okay? So for you all, this is the max that you will deal with, but who knows, you might deal with worst case scenarios, so you never know. But just understand that this is the core concept. So basically, the number 517.364 means the 5 goes in the 100, 1 goes in the tens, 7 goes in the units. Obviously, you have the decimal point there, and then you have 3 tenths, 6 hundredths, and 4 thousandths. Okay. Now, you just got to know which one is bigger or which one's smaller sometimes, especially when like the numbers look pretty similar. Now, as you can see in my example here, I've got both 362.581 and 362.549 written out. As you can see here, the 8 is bigger in the hundreds, so that means 362.581 is technically the bigger number. Okay, so larger is 362.581, and then smaller is 362.549. Okay. Now, to convert decimals, it's pretty straightforward. It's like this, okay? So, you're basically gonna be like this. How many numbers are after the decimal point? So, how many numbers after decimal point? Okay? So, in my case, I've got 1 here, I've got 2 here, and I've also got 2 over here. Now, for my very first one, since I only have 1, basically you're just gonna add 0 in denominator, denom, by how many numbers after decimal point. And what you would set it up like is you put the 3 or you put the number after the decimal point in the numerator, like so. You're going to write a 1 and you're just going to put in the zeros here. So this just officially becomes 3 over 10. In my second one, I'm going to write 25 in the numerator, put a 1 there, and I'm going to add the amount of zeros depending on how many numbers are after the decimal point. So because I have 2, it now becomes like this, 25 over 100. And then finally, for this one here, I got 3.07. So I technically only have 2 numbers after the decimal point, and I'm going to put in 2 zeros afterwards. Now you can write it like this, or you can write it as 307 over 100. That's perfectly fine. Okay. Now, so this is converting decimals to fractions. Very straightforward. Now we're going to learn how to do the opposite. So we're now converting fractions to decimals. Now, if the denominator is a 10, 100, 1,000, move the decimal point to the left by amount of zeros. Okay? So in my case here, I've got 239 over 1,000. So I'm just going to write the number 239 first. As you can see, the decimal point is just right here in black. And because 1,000 has 3 zeros, got 3 zeros, I'm going to go backwards 3 times. So 1, 2, and 3. And that's where my decimal point will end, right here. And that's why my final answer is 0.239, like so. Okay. Let's see, what's this one? Now, if the denominator is not, okay, you need to change the fraction to an equivalent one. And basically what you're going to do is you're going to divide both the numerator and the denominator by a certain number until you get a denominator of 10, 100, or 1000. That's basically it. So in my example here, I've got 3 over 20. I could have done the division route or the multiplying route. It doesn't really matter. You're going to end up with the same one, okay? So in this case, I multiplied by 5. So 20 times 5 is 100. And then 3 times 5 is 15. So I ended up with 15 over 100. And then because you learned how to convert from fractions to decimals like so, using this step here, you'll end up with 0.15. Now, if I did it the other way, 3 over 20, and then I'm going to change this to 10, as you can see, it sort of gets a bit tricky. If I were to divide this by 2, you'd have to do 3 divided by 2, which is not really easy to do. But if you know the answer, then the answer is technically 1.5 anyway, and you're still going to end up with the same answer. But just go with whichever one makes it easier, okay? Don't always go for the smallest one you can do. Go to the one that makes your life 10 times easier. So I would not recommend doing the second method here. Go with the first method, okay? So let's just go over here. So I'm going to take this, put a denominator of 100. I know over here I need to times by 2. So I have to multiply the numerator by 2 as well. I end up with 52 over 100. And then because of this rule here, I can now just go backwards from the decimal point 2 times. So I end up with 0.52. Just to show you the number 52 here, I've got the decimal point there, go backwards twice, 1, 2, it stops there. So that's where my new decimal point is. I should put 2 in red. And then I just end up with 0.52 there, okay? Now over here, I'm going to put it to 100. Now, if you didn't know, 25 times 4 actually equals to 100 here. Now, do the same thing with the numerator, I get 36. Now, let's just do the same thing. Let's just try and figure it out. So, I've got 36 here. Put the decimal point there. I've got 2 zeros, go backwards twice. 1, 2. My decimal point ends here. And now I'm just adding a 0. So, my final answer is going to be 0.36. Just like so. Now, you're going to learn how to add and subtract decimals. It's pretty easy. Line up the decimal points, then line up the numbers, okay? So I've make sure you do it like this. This is the correct way. Don't do it the other way, okay? Don't just line up the numbers first because your decimal points will be misaligned. So just go based off the decimal point first. Now over here, I've got this big number. I typically like to go from biggest to smallest just to make my life a bit easier. So 103.659 first, and then plus 23.07, and then 9.9. So you're going to be adding all this. But then you're going to ask me like, oh, what do I do with the gaps here? You pretty much just fill it with zeros, okay? That's all you're going to do. Just fill it up with zeros and it'll look a whole lot nicer. And then you're just going to add just like how you would typically when you were adding whole numbers. So 9 plus 0 plus 0 is 9. 5 plus 7 plus 0 is 12. Put the 2 in, carry the 1. 1 plus 6 is 7. 7 plus 0 is 7. 7 plus 9 is 16. Put the 6 in there, carry the 1. 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 9 is 16 again. Carry the 1. 1 plus 0 is 1. 1 plus 2 is 3. 3 plus 0 is 3. And then I get 1 plus 0 plus 0, which just equals to 1. So this is my final answer here, 136.629. Now I've got to do the same thing with subtraction. 9.7 minus 2.86. And like before, I'm going to fill in the 0 like so. Now just apply the same rules as subtracting. Obviously 0 minus 6 doesn't work, so what I'm going to do here is I'm going to cross off the 7, write a 6. and put the 1 next to the 0. This now reads as 10 minus 6, which equals to 4. And then 6 minus 8, that doesn't work, so I'm going to cross it off again. It becomes a 5. No, it doesn't become a 5. What am I doing? So the 9 here crosses off to become an 8. And I put the 1 next to the 6, it becomes 16. So 16 minus 8 is 8. Put the decimal point there, and then 8 minus 2 is just 6. And this is my final answer. Okay? Multiplying decimals by 10, 100, or 1000, it's pretty easy. Move the decimal point moves to the right, same number of places as there are zeros, okay? So in this case, I've got 3.8 times 100. I've got 2 zeros there. So I'm going to write 3.8 first. And then I'm going to move the decimal point to the right twice. So 1, 2. That's where it ends, right here. And in the gaps, just fill in the 0. So my final answer is just 380. Dividing decimals by powers of 10, it's pretty much the opposite. It moves to the left, okay? So over here, 9.753 divided by 1000. I've got 3 zeros, so I'm just going to write out 9.753. And now I'm going to move backwards 3 times. 1, 2, and 3. Just like so. Put my dot there. And then fill the rest with zeros pretty much. So 0, 0, 0. So my final answer is just 0.009753, like so. Now we're going to learn how to multiply decimals just regularly, okay? So step 1 is ignore the decimal points and multiply normally using the column method. That's just the method that I showed you. Step 2, count how many decimal places there are in the original question. And this applies to both numbers. And then step 3 is apply step 2 to your answer. Step 1, counting backwards, okay? So over here, 2.57 times 3. I am just going to write it out like normal. So 257 times 3. And you're just going to figure this out. 7 times 3 is 21. Put the 1, carry the 2. 5 times 3 is 15. Plus 2 is 17. The 7 carry the 1. 2 times 3 is 6. 6 plus 1 is 7. So, and now because over here, I've got 2 numbers after the decimal point, what I typically do is I put the decimal point at the end, and I'm going to count backwards twice. So 1, 2. And that's where my final decimal point is. So my final answer is 7.71. Okay? Now, in my next example, I have 3 numbers after the decimal point, but that'll come into play later. Let's just figure it out like normal. 413 times 96. That becomes 18, carry the 1, that becomes a 7, because 1 times 6 is 6, plus 1 is 7, and then 4 times 6 is 24. 9 times 3 is 27, put the 7 here, carry the 2. 1 times 9 is 9, plus 2 is 11, carry the 1. 4 times 9 is 36, plus 1 is 37, put the 0 there. And now you're just going to add the numbers up. So 8, 14, 6, 9, 3. Now I can just set the decimal point here and count backwards 3 times. 1, 2, 3. So that's where it lands. So my final number is 39,000, 39, oh, not 39,000, 39.648. Okay? Dividing decimals, some key terms you need to know. Divisor, the number you divide by. Dividend, the number being divided. Okay? So these are the steps here. Move the decimal point in the divisor to make it a whole number. If it already is a whole number, you can skip step 1. Step 2, it says move the decimal point in the dividend, the same number of places as step 1, and then you just apply short division. Now over here, I've already done it, but it's a bit messy, so what I can do is I can just redo it, so that's perfectly fine with me. I copied this over from our original slides, but it doesn't have to redo it again. So give me one moment while I fix this up. So in my first example, my divisor is already a whole number, as you can see here. So I don't need to make any changes. I can just set it up like normal, 4 over 35.756. Now what I'll do is I'll just line up the decimal place right there. How many 4s go into 3? 0, so the 3 attaches to 35, becomes 35. How many 4s go into 35? That's 8 with the 3 remainder. And then how many 4s go into 37? That's 9 times with 1 remainder. How many 4s go into 15? That's 3 times with 3 remainder. And then how many 4s go into 36? That's exactly 9 times. So my final answer is just 8.939. Now over here is where I need to make the changes. My divisor needs to move twice. So if that happens, then my dividend also needs to move twice. So just to rewrite my question, it now becomes 6413.7 divided by 3. And then you just set it up like normal. Like that. I'm going to put the decimal point exactly there, and then you just go at it. 3 goes into 6 twice. 3 goes into 4 one time with 1 remainder. 3 goes into 11 3 times with 2 remainder. 3 goes into 23 7 times with 2 remainder. And then 3 goes into 27 9 times like so. So my final answer is just... my final answer is just 2137.9. Okay? Final thing, terminating decimals. Terminating decimals are just decimals that end after a certain number of digits, okay? So I'm just going to show you how they look like. So over here, you can't really do much, so just apply short division. Okay, so 4 by 1, like so. Now, this is a hidden trick that a lot of people don't know. What I like to do is I like to put a decimal point here after the 1 and just put it exactly there as well. Because technically, after the 1, you just have a whole bunch of zeros afterwards, okay? Now, obviously, you don't know how many you need, so just chuck in a couple for now, and then we'll just go from there. So 4 goes into 1 time, no times, so you just put a 0 there. The 1 gets attached to the 0, and this becomes a 10. So how many 4s go into 10? 2, with a 2 remainder. And then how many 4s go into 20? Exactly 5 times. As you can see here, my decimal just stopped. There was no more remainders, so I don't need to write anymore. This is my final answer. So equals 0.25. Same thing with here. I have 7 divided by 8. Put the decimal point afterwards. Put it there as well. I'm just going to chuck in 1 0 for now, but I never know when I need it. So 8 goes into 7 0 times. The 7 gets attached to the 0 here. It becomes 70. 8 goes into 78 times. So you see here how I'm just adding zeros as I go. So add the 0, 6 remainder. Keep going. 8's going to 60, 70 times. So that will be a remainder of 4, if I remember. And then 8 goes into 40, exactly 5 times, like so. And as you can see, I have no more remainders. It's cut off there. So my final answer is 0.875, like so. Next thing I got to teach you is recurring decimals. They're just decimals that repeat forever in the pattern. Okay? So you got 2 methods here. You got to put a dot above the digits to show the start and end of a repeating cycle. End of repeating cycle. And method 2 is just draw a horizontal line. Now, my advice is dot for one number, line for 2 or more repeating numbers. This is my general advice, okay? So in my example here, I got all of this laid out. You can just copy it, read it, you'll get it, okay? And then sometimes you just have to do it yourself once you're doing all this division stuff, okay? Um, Now for the first one, it's pretty simple. I'll just write it out like this. So it becomes 0, the 2 gets attached to the 0 here. And as you can see, 3 goes into 26 times, there's a remainder of 2. And then, oh shoot, hold on. 6 times remainder of 2, 6 times remainder of 2, 6 times remainder of 2. You sort of start seeing the pattern. So you can just safely say, hey, it's just 0.6. And because my advice to you was put a dot for one number repeating itself, just put the dot above the 6. You're done. Now for this one here, you need to convert it to an improper fraction first. So this becomes 26 over 7. And this is a pain to do. Okay, it's going to take a while, but you're just going to have to push through it. Okay, so 3 goes into this. Oh no, hold on. 7, no, yeah. 7 over 26, like so. Put the decimal point afterwards. I'm going to fill in a couple of zeros because I know it's going to be long. But you won't have that foresight yet. I've just done this because I know it's going to be long. So let's just go do it. 7 goes into 2 no times. Put a 0 there. The 2 gets attached to the 6. 7 goes into the 26 3 times. And then there's a remainder of 5. 7 goes into 50. 7 times exactly with 1 remainder. 7 goes into 10 1 time with 3 remainder. 7 goes into 34 times with 2 remainder. And then 7 goes into 22 times with 6 remainder. And then 7 goes into 68 times with a 4 remainder. So as you can see, it just keeps going and going and going. Let's just fix this up. So 7 goes into 45 times with 5 remainder. And then vice versa, it just keeps repeating itself. 7 with 1, and then 1 with 3, and then 4. And you sort of see it starts repeating itself, yeah? Because like this is technically where the cut-off line is. So as you can see, that's where it sort of starts repeating itself. So now what you can safely do is, hey, my answer is just 3.714285. But because I have multiple numbers repeating itself, I can just draw a line from the 7 all the way to the 5, and now I am done. Finally, you need to learn how to round decimals. So it's pretty straightforward. Look at the digit after where you want it to round. If it's 5 or higher, round up. If it's 4 or lower, round down. And what we mean by round down, this means stays the same. So I'll show you. Okay? So 51.34721. I'm gonna just write it out like that. So decimal places just mean how many numbers. This just means how many numbers after decimal point. Okay, so because we're going up to 2, so I know that I'm going up to the 4. Okay, so the 3 4 is my benchmark. That's what I'm rounding. Now what you're going to do is you're going to put an invisible line right after the 4, and what happens here is this number highlighted underlined in black determines whether orange increases by 1 or it stays the same. Now our rule was 5 or higher, round up. Because it's a 7, we are going to round this up. So my 4 now becomes a 5. So your final answer would technically be 51.35. And now you're done. Now I'll do this one as well. This is for 3 decimal places. So let's just do this real quick. So where's my blue? So I know 3 decimal places is right there. Purple line goes after the 7. Black here determines whether orange changes, like increases by 1 or it stays the same. Now, because it's the number underlined in black is a 2, that means my 7 rounds down, aka stays the same. So my answer is just 15.357, like so. And then you just follow the same exact steps on this one. You have 1, 2, 3, 4, 4 decimal places. Go this. Black determines whether I round orange up or down. And then because I'm rounding up, that means it becomes 4.8620. What you want to do is, if you were to cover the 4, if the 4 didn't exist, so if the 4 didn't exist at all, if you read that number after the decimal point up to the purple line, you read this as 8,619. Now, if you round up, the next number that could possibly be is 8,620. Okay, so that's why when you rounded the 9, it turns into a 0, but then the 1 also increases as well, because if you read it like that, it makes a lot of sense. Okay, so that's what you got to do. So just study hard. Good luck. Sayonara.